Hello everybody, my name is Christian Collins. I'm going to be doing chapter 3's homework. This one is going to be specifically key example variation problem 3.12. To start off, part A asks us about a cyclist going around the track at 10 meters per second and he has a centripetal acceleration of 5 meters per second squared. What is the radius of the curve? So with this, we know that the acceleration is given. So we're just going to write out this equation here. We're just going to switch out we're going to switch the variables around so we can find radius. And then we're just going to substitute what we've been given, which would be 10 meters per second squared over 5 meters per second squared. This will just go out to be about 100 over 5, making your radius 20 meters, 20.0 meters. That's for part A. Everything that we need is given already. So yeah. We're going to move on to part B now. Part B is asking us to find the period of motion. So to find that, we're just going to use this equation here. The period t, time, so this is going to be t, is the time to complete one full revolution is given by t equals the circumference of a circle over speed, right? That will equal t equals 2 pi r over v. And then we just plug in the numbers that we've got from the problem. So that would be 2 pi times 265 meters over 40.0 meters per second. Do the math there. We get 1664.1 over 40.0, and now equal 41.6 seconds. That's for that answer. Now we're going to go on to part C. Part C is part C. Give me a second. Part C is asking us calculate the car's centripetal acceleration. If you will let me do a second, so to find that, we will. Sorry, I'm blanking real quick. Centripetal. Okay. We know the equation because we're given it earlier, or we know about it earlier. So that would be this, and then we're just gonna plug in what we have already. Should be that squared over 265 meters. So with that, we're going to find out that this is 1600 over 265. And then we're going to just calculate that. 6.04 meters squared is your answer. We're just using the equation for centripetal here on part C. Yeah. And then now we're going to go on to part D, which is asking us to, it states, the wheel of the stationary exercise bike at your gym makes one rotation in 0.670 seconds. Consider 2 points on this wheel. Point P is 10 centimeters from the rotation axis, and point Q is 20 centimeters from the rotation axis. Find the speed of point P on a spinning wheel. With that, we know the linear speed of a point on a rotating object is given by V equals RW. So we know that R equals 10.0 centimeters. So we're going to convert that to 0.10 meters. And then W is the angular velocity of the wheel. So with that, we're just going to plug in some of these numbers. This is going to be the angular velocity. This is the equation for it. W equals 2 pi over 0.670. This would equal to 9.38 radicans. Imagine. No, I'm joking. Rad per second. And then with that, to calculate everything, you'll do 0.10 meters times 9.38 rad per second. That will equal 0.938 meters per second. Simply, we're just using this first one, which is linear, which is the linear speed of a point rotating on a given object, and then this is just the angular velocity of the wheel. That's how you find the angular velocity. So that's part D in the books. We're gonna move on to part E now. Just get everything cleared here. Part E is asking, is saying find the speed of point Q on the spinning wheel. So again, we're going to write out that equation from earlier. And then we know that RQ is given to us, but we're going to convert 20 centimeters to 0.20 meters. Just going to do that conversion here. And we already know the velocity. We already know this number we got earlier. We already know this one. We did it earlier in question D. So we're just going to do the same thing. We're going to do 0.20 meters times 9.38 rad per second. And that will mean that equals 1.88 meters per second. All of this is given to us. We just converted it into meters. And then we used this from the previous problem, multiplied it, and then that's how we found our speed. Very simple. Yep, we already did all the work beforehand, and we did all the hard work in part D, and then now we just gotta finish it out. Let's just do it on part F now. Okay, part F is asking find the centripetal acceleration of point P. So with that, you already know the equation. I'm just going to write it out again. That's the equation for that. And we're going to do A rad P equals RPW squared. So we already know that. We already know this one equals 0.10 meters. So with that, we're just going to do 0.10 meters times 9.38 squared. We're just doing this. And then that would equal 8.79 meters per second squared. That is the centripetal acceleration. So for now, we are going to go on to question G. Part G, actually. Part G is going to be asking us a very simple question of find the centripetal acceleration of point Q now. So that's what we're finding. So we're going to do the same thing. Write this out. Right? We know that AC equals that. And then again, we're going to convert 20.0 centimeters to 0.20 meters. With that, we already know that it's 9.38 rad per second. So again, we're just going to do 0.20 meters times 9.38 squared, which will equal 0.20 times 87.97, which ultimately equals to 17.6 meters per second squared, giving you the answer of of this centripetal acceleration. That's what that is. Again, we're just using all the stuff we've known from previous problems and implementing it into the next one. Anyways, we are going to go on to question I. We're skipping H. Actually, no, we're not skipping H. I'm going to give you why. H is asking for points on the spinning wheel as the distance of the axis increases due to speed and centripetal acceleration increase or decrease. I put both the speed and the centripetal acceleration increase. So for part I, it gives us a graph thing. It shows us the orbital radius of Venus is 1.08 times 10 to the power of 10, like to the power of 11. And the one underneath that is 1.50 times 10 to the power of 11, which is Earth. And then Mars is 2.28 times the 10 to the power of 11, giving us the orbital period of each. So with that, you're just going to write out time on Venus to make a full rotation is 25 times 86400 equals 1.94 times 7. Okay, and for Earth, it'll equal 365 because that's the full rotation, times 86400 equals 3.16 times 10 T to the power of Mars equals 687 times 86400 equals 5.94 times 10 to the power 7. You know that I just told you. To compute the orbital speeds, you will have to do, you know what R equals now. And then for that, you'll just do Venus. I'll do this one for Venus first. Goes 2 pi 1.08 times 1011 over 1.94 times 10 to the power 7. Well, again, we're just using what we did earlier right now. That's what we're doing. And when you put that in the calculator, you'll get 34.9 kilometers per second for Venus. And for Earth, it'll be 2 pi 1.50 times power of 11. These are also given in the graph. And that'll be 3.16 times 10 to the power of 7, which would ultimately equal to 29.9 kilometers per second once you put it in the graph, in your calculator. Same thing for this one, Mars. We're going to do the same thing. It's 2 pi times 2.28 times 10 to the power of 11 over 5.94 times 10 to the power 7. That will equal 24.1 kilometers per second. Pretty much that is the speeds of the rotations of Earth, Mars, and Venus, of their orbital rotations. Okay. Now we're going to move on to part J. Okay, we're just going to move on to part J. Oh, I could just do that. Okay. I didn't know that. Okay, so we're going to go to part J, which is use the data in the table above to find centripetal acceleration of each planet. Okay. So with that, we know this beautiful. My fault. My bad. This is part J. That's not a J. Okay, we know the centripetal acceleration equation. We're just going to do that for Venus. This one's going to be for Venus. That equal 34.9 times 10 to the power of 3 to the power of 2 squared. And then 1.08 times 10 to the power of 11. That'll equal 1.13 times 10 to the negative 2 meters per second squared. That's for Venus. For Earth, it'll be 29.9 times 10 to the power of 3 squared. Over 1.50 times 10 to the power of 11, which would equal 5.95 times 10 to the power of negative 3 meters per second squared. And then for Mars, you're just going to do the same thing. 24.1 times 10 to the power of 3 squared over 2.28 times 10 to the power of 11, which would give you 2.55 times 10 to the power of negative 3 meters squared. That is going to be for part J. Just again using what you know from earlier and then plugging it into here. Pretty elementary stuff. Then I could just clear the page like this. I'm so sorry you had to see me like erase it all the time. Part K is asking, as the size of the planet orbit increases, the speed and centripetal acceleration increase or decrease? Both the speed and centripetal acceleration decrease due to it growing bigger. Okay, we're going into the final parts now. We're going to go into part L. So part L asks, tells us object A is moving at speed v in a circle over radius r. Object B is moving at speed 2v in a circle over radius r over 2. What is the ratio of the period of object A to the period of object B? Okay. For object A, we know. Okay, no. We know the period of circular motion is given by 2 pi r over v. So we know for object A, it will be TA equals 2 pi r over v. And we know for object B, it'll be TB equals 2 pi times r over 2 over 2v. So with that, you just do the math for that. That'll be TB equals 2 pi r over 4v. And then you could just substitute 2 pi r over v to be TB equals TA over 4. And then just to find it, you could do 2A over TB equals 4, which gives you the answer of the ratio. That's just using what you know from, we can substitute these. You can substitute this to be this, and then keep the 4 here, and then move that up here, obviously. And then you'll get this, then you'll move TA to this side, and that's how you get your answer for that one. Okay. Okay, part M is the final part of the question. It's asking, what is the ratio of the centripetal acceleration of object A to the centripetal acceleration of object B? So, again, we know this equation. We've been writing it for the past, who even knows, like 30 minutes probably. Just gonna convert all the terms over. There you go. Right? So that's for A. This is for object A. Just put like I'll put that'll be object A. And then this one will be for object B. So again, you're just going to do what you did earlier. K equals 4v squared over 2. That equals 4v squared times 2 over r, which equals 8v squared over r, which would equal v squared over r. This is defined a red b. So then you're just going to put all these all over each other. Those cancel out, and that will leave you with 1 over 8. And then 1 over 8 in decimal form is 0.125. So that is your answer. That should be the whole problem solved. It's a very tedious one, but As long as you know this equation right here, you should be fine for the whole problem. Thank you for taking your time and watching this video. And sorry it's like a little bit slow, but just gotta get it out the way, you know what I mean? Alrighty. Have a good night, and yeah, I'll see you in class Monday.